Hello everyone. Welcome back to Dr. Liu's VCE Chemistry channel. Today, let's learn together about the 2019 NHT Chemistry. We will focus on questions related to volumetric and chromatographic analysis. My explanations may need to be revised. If any teachers, parents, or students find errors, please feel free to provide your guidance. A student is designing an experiment to determine the concentration of aspartame in soft drinks using HPLC. Aspartame, benzoic acid, and caffeine are all common components of soft drinks. Under some conditions, they have similar retention times in an HPLC column. The graph below shows the retention times for these substances at different pH values. The largest difference in retention times will produce the largest separation. After reviewing the graph, we find the largest difference at pH 3.0. So, A is correct. State the methods to minimize sources of errors and uncertainty. Diluting the sample's dose, not influence. Since this experiment is focused on the pH, the type of mobile phase is not related to errors. Although the pH is an independent variable, an increase in pH just extends the curve, but does not influence the errors. This graph shows that only one experiment is complete. One-time experiments cannot be repeated. So, repetition of the exercise should reduce the impact of errors and the uncertainty, thus making results more reliable. This question is related to titration. The titration of ethanol against permanganate is a redox titration. However, phenolphthalein is an acid-base indicator. So, A is incorrect. The endpoint of a weak acid against a strong base is above pH 7, and methyl red changes its color below pH 7. So B is incorrect. Burettes and pipettes should be rinsed with transfer solutions, because water could dilute the solution. So, D is incorrect. Diluting solutions cannot change the total amount, but can increase volume. However, the absolute uncertainty of burettes and pipettes remains constant, so an increase in volume decreases the relative errors of results. HPLC is constituted of a stationary phase and a mobile phase. As the components in solution are swept forward over the stationary phase by the solvent, they undergo a continual process of adsorption onto the solid stationary phase, followed by desorption back into the liquid mobile phase. Since each component in the ink undergoes these two processes to a different degree, the components separate, polar molecules like the polar, and the nonpolars like the nonpolar. In option A, butane is nonpolar, so it will be more strongly attracted to the nonpolar mobile phase, hexane, than butanoic acid, a polar molecule. In all other options, the mixture contains chemicals that are both polar or both nonpolar, so the differences in attraction to the mobile phase and retention times will be less significant. An experiment is performed to check the accuracy of laboratory glassware for measuring volumes of liquid. A pipette and a measuring cylinder are selected in this experiment. After being cleaned carefully, they are used to transfer the distilled water to a dry, per-weight beaker. Weigh this beaker immediately and accurately, and record the mass of water in the beaker. Repeat the above steps 5 times. Students organize the data in a table. The range is the difference between the maximum and minimum value. Step 5 of the procedure is repeating the experiment. This step is used to minimize random errors. Please read this sentence. A student chose a clean 25 ml pipette with a stated delivery volume of 25 plus or minus 0.03 ml at 20.0 degrees Celsius. So, the range of mass should be within 0.06 g for a pipette. The data in the table show that the range is within 0.03 g, so the data is close together with no outliers. Find the 22.5 on a horizontal level, and the response to 22.5 on a vertical axial is 0.99766. Please give 5 significant figures. The scale is 4 numbers, so we should estimate the last number as the 5th number. We know the mass and density, and then substitute them into the equation to get the volume. There is a difference between the temperature of 20.0 degrees Celsius stated on the glassware and the temperature of 22.5 degrees Celsius, at which the experiment was conducted. However, we should use the water density at 20 degrees Celsius to calculate the volumes so that the average volume calculated is not affected. Compare the accuracy and reliability of the two pieces of glassware for the measurement of a known volume of water using evidence to support your response. The wider range of volumes for the measuring cylinder suggests that the results are less reliable and less accurate than for the pipette. Pipette data is more precise since results are more accurate, closer to the true value, and are more reliable due to the narrower range of results. To measure the concentration of sodium hydroxide with titration, we should use a pipette to transfer the sample because a pipette is greater accuracy due to a narrower meniscus than a measuring cylinder. The pipette and burette are standard instruments for titration. In volumetric and chromatographic analysis, 4 multiple-choice questions are worth 4 marks, and 1 short-answer question is worth 13 marks. The overall score for this section is 17 marks. With a total possible score of 120 points, the percentage for this section is 14.2% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.